Alright, so now we're going to look at significance tests for mu sub 1 minus mu sub 2. Say 2 sample t-test for the difference in two means. Alright, and so the first thing is we want to state, and you can guess on the difference, okay? So sometimes we do think that there is a difference, okay? And then states what kind of difference we expect as our alternative hypothesis. So it could be greater than, less than, not equal to. Often, though, our null hypothesis is going to be no difference. So just like it was when we were dealing with proportions, this is probably going to be our most common. So your null hypothesis is often going to be mu sub 1 minus mu sub 2 equals 0, or you could just say that the means are equal to each other. Okay? And you still need to use your words for the true mean, blah, 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 and use the true mean of whatever this population is, using your words. You still need to state your value. If not given, we're still going to use 0.05. So that's cutting off there. Alright. And your plan, you gotta state the test name. It's a 2 sample t-test. Okay, so remember that significance tests, confidence intervals. Alright. You can prove if it's random or not if it comes from 2 independent random samples or from 2 groups. In a randomized experiment, you can do the 10% condition for independence. When sampling without replacement, and check that 10 times n sub 1 is less than or equal to the population of the first group, and n sub 2, 10 times n sub 2 is less than or equal population of the second group. Then you have your normal or large, so it's either it's a normal distribution that's stated, or you can use CLT and say that they both have larger than 30, or you can check your graph and graph out the little dot plot and make sure there's no outliers, no strong skewness. Okay. You still have your test statistic, which is going to be your t, is going to be equal to the stat minus the parameter divided by the standard error. Okay? And if you have that we are going to have a greater than, then you'll graph it out, and you'll find your t, you'll label it on the graph, and you'll draw it out. If it's less than, then you'll have a lower shaded in region. And if it is not equal, then you will have a two-sided test. Okay. And I mean, you can leave that negative or positive, however you want to do it. It will be a negative value as well. I went ahead and labeled that. Alright, so if the hypothesis difference is 0, or this, you can use these, would also work, but it does not work if you have another number, because then it wouldn't make sense unless you had the other number in there as well. Okay? And then you'd still have your conclusion. So since the p-value such and such is less than or greater than the alpha of that number, we reject or fail to reject our null, and there is or there is not convincing evidence that the alternative is true. So if p-value is less than the alpha, we reject. P is greater than alpha, we fail to reject. It's just a reminder. Alright, so you would use menu You want to use your calculator for this. 6, which is your stats. 7, ooh, I'm all the way out of there, I'm sorry. 7 stats test. And 4, 2 sample T test. It is not pooled. We only pool when dealing with proportions. So if you do it on the calculator, you still need to write on your free response the name of the test, give your test statistic. So tell me what your T is equal to. You still need to label your degrees of freedom, and it's the smaller n sub 1 or n sub 2 minus 1. You still need to write down your p-value, and you still need to draw your distribution, your t distribution, and shade the appropriate. Okay, so you still have to do your state, your plan, and your conclude, but this would be how it would be different for the do. Alright, so let us do an example. Alright, calcium and blood pressure. Okay, does increasing the amount of calcium in our diet reduce blood pressure? Examination of a large sample of people revealed a relationship between calcium intake and blood pressure. The relationship was strongest for black men. Such observational studies do not establish causation. Researchers therefore designed a randomized comparative experiment. The subjects were 21 healthy black men who volunteered to take part in the experiment. They were randomly assigned to 2 groups. All right. You do need to remember that observational studies do not establish causation. All right. And we have randomly assigned to 2 groups. So this is an experiment. And so because it is randomly assigned, we don't have to worry about proving our 10% condition, which is nice. Okay. But we will have to see if it's normal or not. So we have to check and see if we have our outliers, our skewness. So it says 10 of the men received a calcium supplement for 12 weeks, while the control group of 11 men received a placebo pill that looked identical. So we have our control group, we're imposing a treatment, so it's an experiment. The experiment was double blind, so it means that the person receiving the medicine and the person measuring their blood pressure both did not know which one they were getting. Okay. The response variable is the decrease in systolic, or the top number of blood pressure for a subject after 12 weeks in millimeters of mercury. An increase appears as a negative number. Here are the data. So group 1, you see that this person's went down 7, this one's went up 4. Down 18, down 17, up 3, up 5, down 1, down 10, down 11, down negative 2. Alright, so we still need to state, okay, so our null hypothesis is that we want to see if there is a difference, okay? That is the goal, right? So we want to see if there is a difference. So we want the group 1, right, to be equal to group 2 if there's no difference. Our alternative is that ideally we want the person that's taking calcium, we think that there is a relationship, okay? So we think that these means should be larger. Okay? And so you would label mu sub 1 is the true mean decrease in systolic blood pressure of healthy black men taking calcium. And mu sub 2 is the true mean decrease in systolic blood pressure of healthy black men taking the placebo. Okay. So here's our state. All right. And it looks like we need to give our alpha still. Okay, so what is our alpha? If it is not stated, we are going to give it an alpha level of 0.05. All right. So here we go. We are going to plan. All right. So the name of this test is a 2-sample t-test because it's a significance test. It is random because we randomly assigned. Okay. We need to check to see if it's normal. And we need no strong outliers. And you can do a box plot, you can do a dot plot. You can choose how you want to do it. Okay, so my lowest one from either group was -11. My highest one is 18. So okay. Right. You could have labeled this differently. Alright. So I'm gonna have my group 1, group 2. So if you have 7, -4, 18, 17, -3, -5, 1, 10, 11, -2, which if you wanted to turn this into a box plot, you could, because there's 10. Then halfway between these two here, which is at 1 and 7. So there's the difference, 1, 2, 3. Okay. And then the third one would be your other. So that would work. Okay. And then you could graph the other one. And you could also use a calculator to graph these. And then draw what you see on the calculator. So you do what works for you. -3, -5, 5, 2, -11, and +11. Oh, this is -11. I jumped. Alright, and -1, and -3. A few more. So halfway between we'll do the 6th one. 1, 2, 3, 4, 5, 6. And then you have there's 5 on either side, so the third one. Alright, so it doesn't look like we have strong skewness or outliers, so no strong skewness or outliers. We assume approximately normal and will use 2 sample t procedures. Alright, so now we're ready to do. Alright, the t-value we're going to use is going to be, so you just type this in on the calculator, which I will show you how to do here in just a moment. So we're in the calculator, we're going to menu, 6, stat test, 2 sample t-test. So we're going to use our data. So you're going to use your brackets, okay? So you're going to have 7, -4, 18, 17, -3, -5, 1, 10, 11, -2. Close out your brackets. Your next one was -1, 12, -1, -3, 3, -5, 5, 2, -11, -1, -3. Close out your brackets. And this was our alternative hypothesis, was that they were not, well, we said that our alternative was that they were, our mu sub 1 is greater than mu sub 2. It was not pooled. We hit OK. So now you have your different information. So you need to write down the t-value that we got, which was 1.604. You need to write down your degrees of freedom that it used, which was 15.59, and you need the p-value from this. So this is the information that you need to write down. So our p-value is 0.0644. Alright, I'm going to take you back over to the camera so I can finish out this problem. Okay, so now that we have this information here, we need to draw out our curve. Okay, it's a t-curve, degrees freedom equal to 15.59. Our value that we were dealing with is 1.604. We're going to shade above. You want to label your p-value equal to 0.064. Alright, so now we're ready to conclude. Alright, so we say since the p-value 0.064 is greater than alpha equal 0.05, because it's greater, that means that we have to fail to reject, right? So we fail to reject H sub O, and there is not convincing evidence that the true mean decrease in systolic BP of men taking calcium is greater than those taking the placebo. Alright, And so there you have it. So now we need to interpret our p-value. So assuming that there really is no difference, or mu sub O, mu sub 1 minus, or mu sub 2 is equal to mu sub 1. So is true, there is a 0.064 probability of getting a difference of, and we need to calculate our x bar sub 1 minus our x bar sub 2 so that we can calculate this. So the mean of the first group, if you add up these numbers here and divide by 10, is 5. And if you add up these numbers here and you divide by 11, we are going to see an average of negative 0.273. So we have 5 minus negative 2 or negative 0.273. So the difference is 5.273. Of getting a difference of 5.273 or greater just by chance. So that is what this p-value means, the probability of getting a difference that great. Alright, that wraps up the notes on significance tests. There's one more page. Hold in there, you're almost done.